Hello and welcome back to Science 10. Today we're going to be talking through atomic structure, and we'll be looking at the different parts of an atom, and by the end of today you should be able to use some of the information that is on your periodic table to tell me, or your teacher, the number of protons, electrons, neutrons, and a couple other things from your periodic table. We're starting on page 14 of the 2024 Science 10 Notes package. Every atom has 3 subatomic particles that make up that element. Remember from last class, we looked through the periodic table of elements and we took a few notes on them. Each element you can think of as being a flavor of atom. And each of those atoms is going to share some of the same properties. They have 3 different subatomic particles that make them up. This part of the atom here, we're going to call the nucleus. That's not the subatomic particle, that is a part of the atom. This is our nucleus. And inside the nucleus of the atom, we're going to have neutrons, and we're going to have protons. Every atom is going to have a nucleus, and almost all of them have both neutrons and protons. At least they have protons in the nucleus. And out here in the orbits, we are going to have electrons. We'll have electrons out here. But you'll also have electrons for some atoms a little bit further away from the nucleus. Here's a textbook diagram of an atom. If you're looking here, in the nucleus we have neutrons. This is the green dots, and protons. Those are the red dots here. And on the outside we have some orbits that have electrons. Notice also here we have these little symbols where by proton it says plus, neutrons, it has a 0, and electrons, it has a minus. That's the charge of these different subatomic particles, and that's going to be pretty important actually. When we look here, electrons, I'm going to be doing these videos, and electrons I'll be doing in blue. So if you have a colored marker or colored pencil, colored pens, feel free to use blue here. Electrons, you might also see the shortcut that I'll write sometimes for electrons is just going to be this E minus. That's for an electron. Protons I'll be doing in red. So I'm just going to color in proton in red. And I might also use the shortcut P with a little plus sign for proton. And because if you were to mix red and blue together and get purple, I'll use that for a neutron. And a neutron symbol is going to be a lowercase n with a little 0. Electrons, their location in the atom is going to be in orbit around the nucleus. They're not going to be inside the nucleus. They're going to be in orbit around the nucleus. They are very small, and another important thing about them is they have a negative charge. So the charge is negative. Sometimes we will just put a minus sign, just like that. Protons, on the other hand, these are going to be in the nucleus of the atom. And you might have guessed this already by looking at the little plus on the P plus symbol, but these are going to have a positive charge. Positive. Neutrons, these are also going to be in the nucleus, just like the protons, but they have no charge. So we say they are neutral. We've got negative charges, those are our electrons. We've got positive charges, those are the protons. We've got no charges, those are neutrons. Protons and neutrons in the nucleus make up most of the mass of an atom. If you recall a few lessons back, we said that matter, which is made up of these atoms, is anything that has mass and takes up space. Most of the mass of matter is going to come from these protons and neutrons. However, most of the volume, most of the space that an atom takes up is actually occupied by these electrons as they orbit the nucleus. The nucleus, this word that you're going to see, the nucleus you can think of as the center of the atom. On your periodic table, you're going to find a lot of information about the atoms of each specific element. This is a zoom in on the specific box occupied by sodium on your periodic table. There's a few pieces of information there. In the corner here, this number 11, this is the atomic number. The atomic number tells you how many protons are in the nucleus of that atom. So I want you to write here, this is the number of protons in the nucleus. If you change this number, you're no longer the same type of atom. You're no longer the same element. Right now, we're at 11. If we were to take away a proton, this is no longer a sodium atom. It will have changed to a neon atom. And if we were to give it another proton, if we took it to 12, then it would be a magnesium atom. It's no longer a sodium atom. The atomic number is going to tell you what type of element you have. And that's based on the number of protons that are found in the nucleus. You can put a note for yourself, just because we're going to talk about ions in a second, that for atoms, the number of electrons, and I'll use the abbreviation, as equals the number of protons. I'll use the abbreviation P+ there. So for this sodium, if this sodium is a sodium atom, then we'll have 11 protons and also 11 electrons. Over here, we have the atomic mass of all isotopes or types of an atom. It says average here, the average atomic mass. That's because the number of neutrons can vary. Atomic mass comes from the number of protons plus the number of neutrons. If you add those two things together, you will get the atomic mass. This word isotopes, we'll deal with that later. Essentially, the number of neutrons can vary, but for sodium, it's always going to have 11 protons. There's a little bit of a line on your periodic table here, and then underneath that line, there is going to be a charge on many of the atoms on your table. This says Na+, sodium. This is the ion symbol. An ion forms when an atom gains or loses electrons. Ions form when, oops, that's the highlighter, when atoms gain or lose electrons, they form ions. We'll talk more about ions in a future lesson, but for here, essentially what you should know is that on the bottom of your periodic table, this is showing you that charge that happens after this particular element either gains or loses electrons. this ion symbol is the charge that happens when this element gains or loses electrons. I'm going to use the color blue for the word gains. That will come back later. Or loses electrons. Some atoms have two charges. For these atoms, the top ion is the charge of the most common ion. I have your copy of the Science 10 periodic table at center high here. An example of that, if you have your periodic table with you, let's just look at titanium here, that's number 22. You'll see that titanium has more than one possible charge. We have titanium 4 plus and we have titanium 3 plus. The more common one is the one on top, so titanium 4 plus. The state of matter is indicated by the shading of the box. If the box is unshaded, like this sodium is here, then it is a solid at room temperature, at standard atmospheric or standard ambient temperature and pressure. Remember that all of these states of matter are at SATP. If the box is shaded in black, it is a liquid, so this is a typo here. Liquid is going to be black, and gray is going to be gas. I'm just going to take us back over here. I'm going to take us to the second page of the periodic table. The two elements that are going to be liquids at SATP are mercury and bromine. You'll see that they are in fact shaded black, not gray on this periodic table. You can also see there's a legend, in case you forget that if it's just white, there's no specific shading like boron or carbon or aluminum or silicon. They are solid at SATP. If it's black, it's a liquid. If it's gray, it's a gas, like all of these noble gases here, as well as these halogens, fluorine and chlorine. We also have this little kind of cross-hatching for some elements that seldom form ions. You'll see boron, carbon, and silicon. All of these ones have this cross-hatching because they don't often form an ion here. Whereas the ones on this side, these nonmetals, they have their ion here, and the metals have their ion here. Again, more on ions in a future lesson. This is just getting used to your periodic table. Now, you can use your periodic table to try and fill in the chart below. I'm going to work through two of these with you. I'll do chlorine and magnesium, and then I'll invite you to do the rest. And you can check your answers against your teacher's Google Classroom, but I'll do the first two rows with you. First, we'll find chlorine. So if you go to your periodic table, it's going to be on the second page there. Chlorine's right here. We can find its atomic number is 17. That's the number in the top left corner. Its atomic mass is 35.45 grams per mole. It's in the 17th group. Remember, group numbers are along the top. This is the column. It's in the 17th group. It's in the third period. You're going to always start counting periods from hydrogen and helium. So that's one row, two rows. It's in the third row. It's a nonmetal because remember we have this staircase here that is separating metals and nonmetals. And it is going to be a gas because it is shaded gray. So we can fill that information in over here. The symbol for chlorine is Cl. Its atomic number is 17. It has an atomic mass of 35.45. It's in group 17. Period 3. It's a non-metal, which I'll put Nm. It's a gas. And if you remember from last lesson, the name we have for group 17 are the halogens. They're called the halogens. That name means salt generator because they form salts with the alkali metals, group 1. Magnesium. Why don't you try magnesium? Go ahead, pause the video now, and then try finding the information for magnesium here. This is how you would go about finding the information for magnesium. If you're looking here, magnesium is number 12. Often it takes some time just to search around the periodic table when you're just starting with it to find the elements that you're looking for. Magnesium, right here, number 12. It's got an atomic mass of 24.31. It's not shaded, so it is a solid at room temperature. It's in the second group, because it's in the second column. But like chlorine, it is in the third period. You can count 1, 2, 3 periods down. And the family name for it is the alkaline earth metal. So we can transfer that information over here. Mg is our symbol. The atomic number is 12. The atomic mass was 24.31. Excellent. It's in the second group, third period. Metal or non-metal. It's on the left side of the staircase, so it is going to be a metal. It is a solid at SATP, and its family name is the alkaline earth metals. The last one I want to touch base on here, if you're given a group number and a period number, you can use that just as easily as the name or the symbol or the atomic number to find it on the periodic table. Group number, remember, is the column number. Period number, that's going to be our row number. So we're looking for group 17 over here, period 5. So group 17, period 1, 2, 3, 4, 5. That's going to be iodine, and I'm sure that you can fill in the information for the rest of the table on iodine. That's going to be it for today. The next lesson, we're going to talk about atomic history and how we came to our understanding of how we have these different subatomic particles in an atom. Again, today we talked about electrons, we talked about protons, we talked about neutrons, and how to use your periodic table to find information about an element.